Hello everyone, welcome to my channel. In this lecture, we will discuss about the adsorption of phenol with the help of activated carbon in the Aspen adsorption. So first of all, we will open the Aspen adsorption. We will go to the component, double click on configure property, click on use Aspen property system, click on add using Aspen property. So from here, we will go to the Aspen Plus. Aspen Plus window will open. We will add our component, which is phenol, and phenol will adsorb on activated carbon. The activated carbon is adsorbent, and it will use to adsorb phenol. So here we will use the activated carbon for the adsorption of phenol. So it will take some time. Aspen Plus window, this is Aspen Plus. We will go to the component, and here we will add our component, which is phenol. Now click on next in the Aspen Plus and add property. So we will add property. I am using the Finn-Robinson equation of state. Click on next, click on OK. Go to the Aspen adsorption, click on OK. Again go to the Aspen Plus, click on yes. Go to the Aspen adsorption again. So now double click on default, and this is the component phenol, and the formula is C6H6O. Click on this, select the component, click on this arrow, and click on OK. So we have added our component from Aspen Plus to the Aspen adsorption. Now we will go to the gas dynamic model. So you can go to a gas dynamic model from the library, from the AdSim and gas dynamic, this one. But here this is another method. So from here we can also add the gas adsorber, the gas feed and gas product. So I'm using this one. Drag and drop the gas bed, the adsorber, the gas feed, the gas product. You can rename this. Click on this one, rename block like add feed. This is feed. B1 is the bed adsorption column. B3 is the product. This is the product. Okay. This is the feed. Now connect the feed to the adsorber and connect product to the adsorber. So go to the connection, click on gas material connection. This is a gas material connection stream. Connect feed, connect product. Okay. Now double click on feed and add feed information. Click on specify. So the molar flow rate of the feed is this one, and this is the composition of phenol in the forward direction inside the adsorption column. The temperature of the feed is suppose 300 Kelvin. I'm assuming these value, so you can add your own value from your problem. And suppose the pressure of the feed is 5. Okay. Now go to the bed adsorption column. This is the vertical. There is one adsorption layer inside the adsorber. So there is one layer of activated carbon inside this adsorption column. Adsorbent is activated carbon. So the adsorber is in vertical position, and there is one dimensional flow inside the adsorption column. There is no heat exchanger inside this adsorption column. So click on the adsorber and the general. The discretization method we are using UVS1, and number of node is 20. The momentum balance is the material balance assumption. This is convection only problem. The momentum balance, you can use the Karman-Kozny equation, but I'm using the Argan equation. From the kinetic model, the film model assumption, I'm using the solid. You can use fluid. Kinetic model assumption is lump resistance, and the form of lump resistance and the form of mass transfer coefficient is constant. So it can be constant or arrhenius. The isotherm, I'm using the Langmuir isotherm. You can use the Freundlich, Langmuir Freundlich. and a BET isotherm. So I'm using the Langmuir isotherm, and the isotherm will depend on the partial pressure. So it can depend on the partial pressure or concentrations. In case of gaseous system or gaseous system, we are using partial pressure, and for liquid adsorption, liquid component adsorption, like for the adsorption of heavy metal ion or for the adsorption of dye, we are using the concentration, because these are the because dye and heavy metal ion, we are usually dye and heavy metal ion solution are usually in the concentration, and the gases are in usually in the partial pressure. So this is the partial pressure and the energy. This is a isothermal model. There is no reaction in the adsorber, and go to the specification. The height of the adsorption column is 1 meter by default, but I'm using 0.4 meter, and the internal diameter of the adsorption column is I'm using 0.13 meter. The interparticle voidage or the porosity of the column, the distance between particle inside the adsorption column is suppose 0.2. The word fraction, usually the word fraction in the adsorption column is usually from 30 to 40%, so I'm using 40%. The intraparticle voidage is suppose 0.15. I'm just assuming this one. The bulk density of the adsorbent, so the density of activated carbon is usually, I'm assuming 2000 kilogram per cubic meter, and the particle radius, the adsorbent particle radius is this one. So 1 millimeter particle of adsorbent. So the adsorbent particles which are using in the adsorption column will be 1 millimeter. The adsorbent particles will be 1 millimeter in size. The mass transfer coefficient, here you can use your own value, but I am just leaving this one. But suppose I am changing this one to 0.07, and the isothermal parameter. So this can be obtained from the adsorption isotherms for phenol. So I'm just using this one to 1.4 and this to 1, and the direction is 0. Click on yes. Click on present initial. Close this one. Click on initialize. Click on yes. Close this one. Close this one. Go to the product. Click on specification. This is okay. This is the 1 bar. Okay. Close this one. Now go to the initialization. Run the simulation. So the run is completed. Now we will make some plot, like we will plot some the adsorbent uptake versus time. So uptake versus time, that how much phenol is adsorbing on the adsorbent surface with the help of time. So I am plotting this graph. Click on OK. Okay, the time for my simulation will be, suppose I am changing the time from 0 to, or the time of simulation will be from 0 second to suppose 800 second, and the grid interval will be suppose 20. Click on OK. Okay, here you can see this one. So I will minimize this one. The grid interval is, suppose I am changing it for better presentation. So this is 100. Okay. Now go to the bed. Okay. Double click on bed and click on again. Go to results, and here go to the solid loading. So the solid loading of phenol, these 1, 2, 3 are the position inside the adsorption column. So I'm just using a random position. Position number 8, position number 1, and position number 20. So I will check that what will be the adsorbent, what will be the phenol the adsorbent uptake at these position number 1, position number 20, and position number at this position, and 20 number position. So okay, I will go to the Click on this one and go to the dynamic mode. So my simulation will be stopped at 800 seconds. Click on take this one, click on OK, and click on run button. This is the run button. So click on run button. So here you can see the time. This is the dynamic, the time. Click on OK. So here you can see the time, and there's the phenol, the adsorbent uptake inside the adsorber with the passage of time. So here you can see this is position number 1, this blue, this one. So here the saturation occur first, at start the saturation occur at point number 1. This is the base of the adsorbent, or the first layer inside the adsorber. So at the beginning, more and more phenol will absorb on the more and more phenol will be absorbed inside the adsorber. So here saturation will occur at very less time. Here you can see at 100 seconds saturation of phenol occur. Now the phenol molecule will go from bottom to the upward position inside the adsorption column. So here you can see saturation occur at about 400 or 300 seconds. But here at position number 20, at the top of the adsorption column, at the top region of the adsorption column, the saturation of phenol will occur at 500 seconds. So here you can see more and more phenol will be absorbed. There will be no adsorption of phenol after 500 seconds at the top of the adsorption column. And here you can see that there will be that equilibrium will occur at 100 seconds inside the adsorption column at the bottom of the adsorption, at the bottom location of the adsorption column. But here you can see this is at number position here, the blue one. So here you can see the saturation or the equilibrium occur at 300 or at 400 seconds. The equilibrium of phenol will occur at 400 inside the adsorption column. So this is about the middle of the adsorber. So at the middle of adsorber, the equilibrium or the saturation of phenol will occur at about 300 seconds. So this was the graph about the adsorbent uptake with the passage of time inside the adsorption column. We can also plot some other graphs, like suppose I'm plotting some other graph. Click on this one. Suppose the temperature, or suppose the pressure versus time. So what will be the pressure of phenol with the passage of time inside the adsorption column? Click on OK and double click on bed. Go to its results and go to the pressure. So the solid loading, the pressure within the element. So the pressure of phenol at the bottom 5. So here you can see the pressure of phenol at position number 1 or position 0 is this one. At the middle of the adsorber is this one pressure, and at the top of the adsorption column, the pressure of phenol inside the adsorber will be this one. Okay, now double click on time. So from 0. So here you can see that the pressure, here you can see the pressure at layer number 1 at the top, the pressure is slowly increases, and here you can see the pressure is the pressure at the bottom is constant, the constant 5 bar pressure. It is constant. The pressure is constant. The pressure of phenol is constant at the bottom of the adsorption column. But here at the middle of the adsorption column, the pressure is slightly increases. It increases, and at 400 seconds or at 500 seconds, the pressure is constant. And the constant pressure after 500 seconds in the middle of the adsorption column is about 3.8 bar. So here you can see similarly at the top, the pressure of the column is the pressure of the adsorption column. The pressure of phenol inside the adsorption column is this one here you can see 1.5 or 1.7. So this is the plot about the pressure versus time. Now I am making some other plot like the pressure and the uptake with the height of the adsorption column. So what will be the pressure of phenol? What will be the pressure of phenol with this height? When we change this height, this is the z direction, suppose. So what will be the pressure of phenol inside this adsorption column with this height? So when we change this, as we go from bottom to the top, the pressure of phenol will be changes inside the adsorber. Similarly, what will be the adsorbent uptake? There is adsorbent or activated carbon inside this bed. So what will be the adsorbent uptake as we go from bottom of the adsorber toward its top? So click on this one, new form, click on profile plot, and pressure uptake, pressure versus Z. Z is the height. Okay. Okay. Now right click on this one. Go to the profile variable. Click on point variable. So on the x-axis, I will add the height. So when we change the height, when we go from bottom to top of the adsorber, what will be how the pressure will be changes as we go from bottom to top, and how the adsorbent will behave, and how the adsorbent uptake will changes as we go from bottom to top. So click on find. So click on find, and here we will go to the distance, axial distance, or the height is the height. Here you can see the maximum height is 0.4. Here you can see. So drag and drop. Okay, this is the height Z, and it is in meter. It is in meter. So meter. Okay. Okay. Now, and the height, this is height, and it is on x-axis. So we will click on the height. Click on x-axis. So we have added one parameter to the x-axis. Now click on find variable, and click on find, and go to the adsorbent, the pressure. The pressure. Here you can see the various density pressure within the element. So this is the pressure of phenol. Okay. Okay, pressure of phenol and layer number 1. Okay, there is one layer in the adsorber. Okay. Now click on find variable again. Click on find, and another variable is uptake or the solid loading. So solid loading and uptake are same thing. So I'm using the solid loading. Solid loading. Here you can directly search. Here you can see the solid temperature, a solid loading. So solid loading or uptake, adsorbent, uptake, and I am removing this 17 position, and in place of 17 I am adding star. So it means that it will be for whole column. For whole column I am using star in place of 17. So plot this one. Also plot pressure on the y-axis. So the adsorbent uptake and pressure will be on the y-axis. on this y-axis, and the z will be height will be on the x-axis. Click on OK. So here we have already run the simulation. So here you can see, as we go from bottom toward the top of the adsorber, then the pressure of phenol will be decreases as we go from bottom to top, because more and more phenol will be adsorbed on the adsorbent. So its molecule, its concentration will be decreases as we go from bottom to top. So when the concentration and molecule of the phenol decreases, then its partial pressure or its pressure will be decreases. Similarly, when the molecule or the concentration of phenol decreases, then it means that the uptake of phenol will also decrease as we go from bottom toward the top of the adsorption column. So here you can see at the height at the top of the column, here you can see the pressure is this one. Here you can see the pressure is this one. It is 1 or something 1. But here you can see this is the uptake. So the uptake at the top is this one. Here you can see 0.8 or 0.89 or 0.9 kilomole per kilogram. So 0.9 kilomole of phenol will be adsorbed on 1 kilogram of activated carbon at the top of the adsorption column. And at the bottom of the adsorption column, at the bottom, at the very beginning, or at the bottom of the adsorption column, here you can see 1.1 or 1.18 kilogram of phenol will be adsorbed on 1 kilogram activated carbon. Here you can see at the beginning, at the bottom of the adsorber, the pressure of phenol is 5 bar, and it is decreases. In the middle, here you can see in the middle, this is the pressure and this is the uptake. So you can go to the property, you can change the legend like this one, like I'm also changing its color, so it can be changes. Click on OK. So you can play with this plot. Thank you very much for your attention. If you are new to the channel, please like and subscribe.